Well, we're now going to begin to start working with matrices. And in my experience, students tend to like these little sections here where we work with matrices. And a matrix is really nothing more than just a way that we can organize data. And we're even going to learn that we can perform algebraic operations on them. We can add and subtract. We can multiply by a scalar. We can do multi-step operations. We can multiply them. We can even use them to solve systems of equations. And after we kind of learn the mechanics, the how these operations are performed on the matrices, then we're going to find that our calculator is really one of our best friends because it can take a lot of the drudgery out of the work. But it's important to understand the why and the how. So let's look at what we have here in this example. It says the table displays U.S. Census data. So we got a table up here that is giving us the Latino population in the U.S. in millions. I don't know what year this comes from. My guess is it's probably coming from the year 2000. Could be 2010, but I actually don't think so. I don't see that it says anywhere. And so we see in this that between the ages of 0 and 19, we've got a certain number in millions of male and female, 20 and 39, 40 and 59, and then 60 plus. So we got population data. And we're first asked to organize the data in a matrix, which we see right here. And if you notice, and putting this in a matrix is very similar to it's almost exactly as far as what the table gives us. So the table itself, you could say, is a form of a matrix. Now, the data that we put in there was the population data of male and female. And we're going to learn that we define our matrix, and this will become important as we move along, by rows and columns. And so this would be a 4 by 2 matrix. It's got 4 rows and 2 columns. But let's see what we're asked to do here. So we put it in a matrix that we see, and it says add the elements. So all the numbers in the matrix are an element, and we could actually define them by their row and column. But add the elements in the column and interpret the result. So in column 1, let's see what we have here. We got 7.1, 6.8, 3.2, and 1.1, 18.2. And what would that mean? That means that we've got, according to this census data, there are 18.2 million male Latinos in the United States. And then what about column 2? So we got 6.6 plus 5.9 plus 2.2 plus 1.4. And there are 16.1 female in our population. So we got more males than we got females. Okay, cool. Now, what about add the elements in the rows? Well, we're just going to add row by row. So between 0 and 19 years of age, we got 7.1 plus 6.6. That's 13.7. Between 20 and 39, we got 6.8 plus 5.9. We got 12.7. Excuse my handwriting. Then we got 3.2 in row 3, which is 40 to 59, plus 2.2, 5.4. And then 60 plus is 1.1 plus 1.4. And this is 2.5. And so this gives us data. This gives us total population, both male and female, within certain age groups. And one of the things that I do notice here is that this seems to be a pretty young population group. Heavily weighted towards 39 and under. Now, the last question would be, would finding the average of the rows and columns, would that provide any data, any meaningful data? Probably not really. I mean, what we're really looking at, we've got it already segmented by age group, and this does give us total population. In the columns, it's male versus female. And in the rows, it gives us total population data based on age groups. And taking an average of that probably doesn't mean very much. In fact, it probably would be meaningless. How about that? Something's meaningless. You might think all of this is meaningless, but it's not.